This is number 9 in our Chapter 3 test review problems, where we're asked to factor the expression completely. Well, the first thing we always look for when we're asked to factor is if there is a greatest common factor. There is not. There is nothing that divides into 6x squared and into 19x and into minus 20 that is the same. The next thing we look at is it a special case? Well, clearly this is a trinomial because it has 3 terms in it. So the only special case that we have studied that is for a trinomial is a perfect square trinomial. In order to be a perfect square trinomial, this first term has to be a perfect square and this last term. That is not the case. So our third option then is going to be to just use the unfoiling method. And the unfoiling method, in this case, would probably be best, to use the grouping method because of the fact that our leading coefficient is not 1. So we need to find factors of 6 times negative 20, which is negative 120, that add up to 19. 5 times 24 is equal to positive 120. And obviously we need it to equal negative 120, which means one of them has to be negative. And the one that needs to be negative in this case is the 5, because then when we add negative 5 and positive 24, we do get our middle term, 19, or the middle coefficient. So I'm going to break this 19x into minus 5x and plus 24x. And I just bring down the leading term and the constant at the end. So now we're going to use our grouping method. Greatest common factor of those two, and then we'll look for the greatest common factor of these two. Well, the only thing that the first two have in common is x. And if we divide out an x, we'll be left with 6x minus 5. If it's factorable, then here we'll also be left with 6x minus 5. Clearly, the greatest common factor must have been positive 4. So now here's our first term and our second term. What do they have in common? 6x minus 5. If I factor out a 6x minus 5, this will go away, and this will go away, and what I have left is x plus 4. If I FOIL those two binomials, I will find that they do in fact equal the trinomial that I began with.